All right, we're talking about triangle inequalities today. First thing is the triangle inequality theorem. It says in order for a triangle to be constructed, the sum of the shorter sides must be greater than the longest side. So technically, the sum of any two sides has to be greater than the third side, but you really only have to check and make sure that the two shorter sides have a sum greater than the longest side. And let me show you why this works, why this theorem is true. Here's an example where I have three segments. I want to try to make a triangle out of this. But right now, if you'll notice, the sum of the green and the orange is still just a little bit less than the brown all by itself. So right here I got a situation where the sum of the two shorter pieces is not greater than the third side, not greater than the longest side. So I am not able to make a triangle out of this. If I try, the problem is those are not long enough to meet up at any point. And so I am not able to create a triangle. To have a triangle, the sum of the two shorter sides has to be greater than that third side. It's the only way you can make a triangle. Alright, so based on that information, let's fill out this table. These are going to be the three supposed sides. We want to say what the sum of the shorter sides is. We're going to put what the longest side is here, and then we'll compare them and see which one's greater or less than or equal to. And then based on that information, we'll say yes, it can be a triangle, or no, it could not be a triangle. So right here, the longest side is 3, and the sum of the two shorter sides would be 4. 2 plus 2 is 4. 4 is greater than 3. So because the sum of the two shorter sides is greater than the longest side, yes, we can make a triangle out of this. Okay, here, longest side is 4. The two shorter sides are 2 and 3, so the sum of those is 5. And 5 is greater than 4. So the sum of the two shorter is greater than the longest. Yes, we can make a triangle out of that. Okay, the longest side here is 5. Sum of the two shorter sides is 5. Alright, this time the sum of the two shorter sides is equal to the longest side. We cannot make a triangle out of that. That sum has to be greater than the longest side. Here the longest side is 6. Sum of 2 and 3 is 5. The sum of the two shorter sides is less than the longest side. No, we can definitely not make a triangle out of that. The sum of the two short sides has to be greater than the longest side. Here the longest side is 5. 3 and 4 have a sum of 7. That is greater than the longest side, so yes, we can make a triangle out of that. And you should be able to kind of pick up the pace here a little bit. Add 3 and 3 is 6. 6 is equal to 6, so no. If that's not a greater than sign, if the sum of those two shorter is not greater than the longest side, then no, it's not a triangle. Now here, there is not one side that's the longest, so it really doesn't matter which one you place in that spot. The sum of the other two is 6. That's definitely going to be greater than the longest side. Yes, you can make a triangle out of that. 4 is the longest side. 3 and 3 is 6. 6 is greater than 4. Yes, we can make a triangle out of that. 6 is the longest side. 3 and 5 is 8. 8 is greater than 6. Yes, we can make a triangle out of that. Alright, determine if the following sides will make a triangle, and if yes, then classify by sides. So remember, if none of the sides are congruent, it's scalene. If two sides are congruent, it's isosceles. And if all three sides are congruent, then that's equilateral. Those are the classification options when you're classifying by sides. So 10 is the longest side. The sum of 8 and 9 would be 17. That sum is greater than the longest side, so yes, we can make a triangle. We do not have any of these that are the same. None of the sides would be congruent, so that would be scalene. Okay, number 2, here's the longest side. The sum of the two smaller ones is 2. That is not greater than the longest side. That's equal to. That doesn't work. No, you can't make a triangle out of that. And obviously, we're not going to classify if it's not a triangle. You can't classify the type of triangle. It's not a triangle. Okay, number 3. 10 is the longest side. 6 and 6 adds up to 12. So the sum of the two shorter is greater than the third side, so yes, that makes a triangle. I have two sides that are the same, so that makes this isosceles. Okay, now number 4, 7 is the longest side. 3 and 5 have a sum of 8, which is greater than the longest side, so yes, it's a triangle. None of the sides are the same, so that's scalene again. And then here, there's not one side that's really longer than the other, so whichever one you want to make the longest side doesn't really matter. 4 plus 4 is 8. That's going to be greater than that third side. Yes, you can make a triangle, and since they are all the same, that makes this equilateral. Alright. In a triangle, the largest side is opposite the largest angle, and the smallest side is opposite the smallest angle. And let me give you another quick demonstration of that. Alright, I'm going to provide these as two sides of a triangle. And just imagine in your mind connecting these 2 points to create that third side of the triangle. Okay? Now, as I make this angle right here smaller, what happens to the length of this third side that we're imagining in our head? As this angle gets smaller, this side gets smaller. Notice what happens to the length of this side as I make this angle bigger. If I make that angle bigger, the bigger this angle is, the longer that side becomes. That's why the longer the side is, the larger the opposite angle, or the larger the angle, the longer the opposite side. Okay, the smaller the angle, the smaller the opposite side. So, right here, let's put the information into the picture. They tell us the measure of angle 1 is 120 degrees. The measure of angle B is 40 degrees. And the measure of angle C is 20 degrees. Alright, what is the largest side? Well, the largest angle is angle A, and it is opposite the side length BC. So line segment BC is going to be the longest side. And then the smallest side, 20 degrees is the smallest angle, and opposite angle C is line segment BA. So line segment BA is going to be the smallest side of that triangle. Alright, some of the pictures in this type of stuff is not going to be drawn to scale, so make sure you're not just eyeballing it and going, it looks like that's the longest. So make sure we're going off the information we're learning today. Alright, classify the triangle by sides and then list the angles from small to large. If I'm classifying by sides, every side is a different length. There's no congruent sides, so that makes this a scalene triangle. Alright, and we want to list the angles from smallest to largest. So the smallest angle is going to be opposite the smallest side. So 9, 12, and 15. 9 is the smallest. So line segment AC is the shortest side, and the angle opposite that side is angle B. So angle B is going to be the smallest angle. The next smallest, 12 is smaller than 15, so line segment AB is the second smallest side, and it is opposite the angle C. So angle C will be the second smallest angle. And then this 15 right here is the longest side. Line segment CB is the longest side, and it's opposite angle A. So angle A is going to be the largest angle. Alright, let's look at example 8. List the sides of triangle ABC in order from longest to shortest if the angles of triangle ABC have the indicated measures. And they give us expressions for the angles. We're supposed to list the sides in order. They didn't give us any information about the sides. They gave us information about the angles. Well, the first thing I need to do is figure out what these angles are. So what do we know about the three angles in any triangle? We know that they add up to 180. So I'm going to add all three of these angles together and set it equal to 180. So I got 10x plus 5x minus 17 plus 7x minus 1. Once I add all three angles together, it should add up to 180. So there's the equation. We combine like terms, so I got 10 and 5 is 15, plus 7 more is 22, so I got 22 x's. Then I have negative 17 and negative 1, so that's a negative 18. Okay, now we want to get x all by itself. Got to get rid of this 18. It's being subtracted, so I'll do the opposite operation and add it. And then we want to get rid of that 22. X is being multiplied by 22, so we'll divide by 22. All right, so that tells me what x is. Now, that's only useful because I needed to find out what the angles are. So I need to substitute that 9 back in on each one of these to find the angles. So for the measure of angle A is 10 times x. If I know x is 9, then the measure of angle A is going to be 90 degrees. Okay, measure of angle B is 5x minus 17. Since I know x is 9, I'm substituting the 9 in place of x. 5 times 9 is 45. 45 minus 17 is 28. So the measure of angle B, 28 degrees. And then measure of angle C, 7x minus 1. We know x is 9. Substitute it in. 7 times 9 is 63. Minus 1 is 62. So the measure of angle C, 62 degrees. So now I know all of the angles. Be careful you don't start listing those in order from longest to shortest, or largest to smallest. We're supposed to list the sides in order from longest to shortest. Now you can do it without a picture, but a lot of people find a picture helpful. Now when you draw the picture, don't stress out too much about what the actual angles are. 90 is easy to remember, so I'm going to go ahead and make that 90. But then B is supposed to be 28. And C is supposed to be 62. Alright. We want to list the sides in order from longest to shortest. Remember, the longest side is opposite the largest angle. Well, 90 is the largest angle, so the longest side will need to be line segment BC. The next largest angle, 62, is bigger than 28, so this angle is the second largest. The side opposite angle C is line segment AB. And then the 28 degree angle, angle B is the smallest angle, so opposite that should be the smallest side. So opposite angle B is line segment AC, shortest side. So there are all your sides in order from longest to shortest. I don't know what their lengths are, but I do know which ones will be longer and which ones will be shorter. Alright, so far everything we've talked about the longest side being opposite the largest angle, smallest side being opposite the smallest angle, that only applies to one triangle, within one triangle. So, for example, if I have two different triangles, this might be an 80 degree angle, and this might be a 120 degree angle. The side opposite the 120 degree angle is not larger than the side opposite the 80 degree angle. They're in different triangles. I can't make that comparison. Okay? What we were talking about only works with the angles and sides within one triangle. However, there are certain circumstances that allow us to make some comparisons between two different triangles. So let's look at the hinge theorem here. If two sides of one triangle are congruent to two sides of another triangle, then the longer third side is across from the larger included angle. So right here, here's two triangles. Notice these segments are congruent, and these segments are congruent. So that fits that situation where two sides of one triangle are congruent to two sides of another triangle. Anytime you have that situation, the longer third side, so now we're looking at BC and EF because those are the only sides we haven't already said were congruent. The longer side is going to be opposite the larger included angle. And when we say that word included, it means it's going to be between the sides. So these sides that we have marked congruent to the sides of the other triangle, the included angle is the angle that's created by those two sides. So angle A and angle D, those are the included angles here. So if we know that the measure of angle A is larger than the measure of angle D, then I know that line segment BC is going to be larger than line segment EF. As soon as you have this situation where there's two sides of one triangle congruent to two sides of the other, when you compare that third side with the included angle, we go back to the same concept of the longer side is opposite the larger angle. Shorter side is opposite the smaller angle. And then the converse is also true. It's still in the situation where there's two sides of one triangle congruent to two sides of another triangle. So you still have to have that going on. Then the larger included angle is across from the larger third side. So if instead of knowing which angle is bigger and determining which side is bigger, instead of doing that, if I first know which side is bigger, so if I know the distance from G to H is greater than the distance from K to L, then I know that the angle opposite that longer side is going to be greater than the angle opposite the shorter side. So the measure of angle J would be greater than the measure of angle M. So let's see if we can actually put this into application here. Write an inequality comparing the distance from A to C and the distance from X to Z. Alright, we got two different triangles here. I notice this one has a side length of 7 and this one has a side length of 7, so those are congruent. This one has a side length of 9 and this one has a side length of 9, so that one's congruent. So now we have two sides of one triangle congruent to two sides of the other triangle. So I can look at the angle that's between those and its opposite side and compare that with the included angle over here and its opposite side. We've got a 119 degree angle here, 111 degree angle here. This angle is bigger, meaning that this side will be bigger than this side. So when I set up this inequality, it should say that the distance from X to Z is greater than the distance from A to C. It's opposite the larger angle, it's going to be the longer side. Now you could also write your inequality in this direction. If we do, we want to make sure we flip that inequality to match. If this one's greater than AC, then AC is less than XZ. Either one of those would be acceptable. Alright, let's look at example 10. It says find the range of values for X. Okay, right here we got two different triangles. Notice these sides have been marked congruent for us. I don't see any other sides marked congruent. But notice that this segment right here is a side length for both triangles. It's the same segment. It's going to be the same length for both of them. So that shared side right there is your second pair of congruent sides. So now I can look at the included angle and its opposite side. This included angle and its opposite side. Notice that this angle is opposite a side length of 8. This angle is opposite a side length of 7. So because this angle is opposite a longer side, it's got to be the larger angle. So the 2x plus 8, it's opposite the smaller side. It's going to be the smaller angle. So this is going to be less than 25. Excuse me. Alright, so now, just like we do with equations, we want to solve for x here. So I'm going to subtract 8. And then we want to divide by 2. Alright, so I know x needs to be less than 8.5. Now, most kids might forget that there's more to do on this problem. If we just say x can be less than 8.5, that leaves open the possibility that x could be negative 1,000. But that would be a problem. If I plug in negative 1,000 right here, if I substitute that in, I'm going to get a negative number for this angle. It's not possible for an angle to have a negative number of degrees for an angle measurement. Every degree has to be more than 0. If it's a 0, there's no angle. It doesn't exist. So it has to be greater than 0. So I need to make sure that this 2x plus 8 is at least representing a positive number. So I'm going to say 2x plus 8 has to be greater than 0. Whatever expression they've given you for that angle or for a side, because sides have to be positive also. You don't ever see negative numbers on a ruler. Whatever that expression is for the side or the angle that they give you, we're going to set it greater than 0 to show it has to be positive. And we'll solve for that as well. So I'm going to subtract 8. And then divide by 2. So it says x has to be greater than negative 4. Now some people are still confused sometimes and they say, I thought it had to be positive. Well, the angle has to be positive. X does not have to be positive. So for example, x is greater than negative 4. That means it could be negative 2. Well, if I substitute negative 2 in here, 2 times a negative 2 is a negative 4. And negative 4 plus 8 is 4. So even though x is a negative number, the angle comes out to a positive 4. And that's the important part. It's not that the x has to be positive. It's that the angle measure has to be positive. So now I have two things going on here at the same time. X needs to be less than 8.5, and x needs to be greater than negative 4. I want to write that as one answer. So this is how we would do that. This shows that x is greater than negative 4 and less than 8.5. So this is our answer to this particular problem.